Welcome to Module 5. This module covers firewalls. A firewall is the device that enforces access control at zone boundaries in your segmented network. We've talked about creating zones with VLANs. We've established the principle of least connectivity, permitting only the specific traffic that has a documented business reason. A firewall is what enforces that principle in practice. Without it, VLANs create organized zones, but nothing controls what crosses between them. By the end of this module, you'll understand how firewalls work, how to read a rule set, what default deny means, what the most common misconfigurations look like, and how to think about secure remote access. Let's start with what a firewall actually is. A firewall sits at the boundary between two networks and enforces rules about which traffic is permitted to cross that boundary. It examines network packets, the data units traveling between devices, checks them against a rule set, and either permits them through or blocks them. Think of it as a security checkpoint at the entrance to a restricted control room. A guard at the checkpoint doesn't let everyone in. They check credentials, verify purpose, and only allow through people who meet the criteria. The firewall does the same thing, but for network packets. A packet presenting with the right source IP, the right destination IP, and the right port number gets through. A packet that doesn't match a permitted rule gets blocked. The firewall's effectiveness depends entirely on the quality of the rules configured on it. A firewall with poorly written rules, rules that are too broad, or rules that haven't been reviewed since commissioning provides false confidence. It's a checkpoint where the guard waves everyone through without looking. The presence of a firewall is not the same thing as effective access control. In an OT environment, firewalls belong at every zone boundary where you want to enforce access control. The most critical placement is between the OT environment and enterprise IT, specifically between the OT network and the DMZ, and between the DMZ and the enterprise IT network. Every piece of traffic crossing from IT to OT or OT to IT should pass through a firewall. A firewall also belongs between engineering workstation VLANs and the field control VLAN. Engineers need access to PLCs for programming and maintenance, but that access should be controlled, not always on and unrestricted. Remote access entry points need firewall enforcement. When a vendor or remote operator connects via VPN, the VPN termination point should be followed by a firewall that controls what the remote user can reach. Landing inside the VPN shouldn't automatically mean reaching every OT device. The principle is every meaningful zone boundary should have a firewall. Each firewall is a choke point where traffic is examined and decisions are made based on rules. Defense in depth requires multiple layers, which means multiple firewalls, not one perimeter firewall and open access everywhere else inside. A single perimeter firewall, one device between the internet and everything else, is not defense in depth. If an attacker bypasses or penetrates the perimeter firewall, either through a misconfigured rule, a vulnerability in the firewall software, or through a legitimate-looking credential obtained via phishing, they should still hit internal boundaries before reaching critical systems. If there's only one firewall at the outer perimeter and everything else inside is flat, a perimeter breach is a full OT access breach. Defense in depth means multiple independent barriers, each providing its own control, each failing differently. A firewall between IT and the DMZ, a firewall between the DMZ and OT, firewalls between OT VLANs for engineering, operations, and field control. Each of these is an independent enforcement point. This is the same logic as layered safety interlocks in process safety. You don't rely on a single pressure relief valve. You have the relief valve, a high pressure shutdown, a high pressure trip, and a physical rupture disk. Each layer acts independently, and failure of one layer doesn't mean failure of all of them. The same principle applies to network security controls. In the next video, we'll cover packet filtering, the simplest type of firewall, how it works, and where it falls short. Understanding its limitations help you understand why more capable approaches were developed and why you still encounter it in older OT equipment.